Hello everyone. Our Team 5 has chosen to work on a firefighting robot as our DIY assignment. Our robot aims to find a new way to save the world from fires. So the problem that we are tackling as of now is that the world is caught up with various fire hazards like forest fires which spread over large areas and which cause damage to a lot of property and humans as well. So to reduce casualties in firefighting, we have chosen to build an autonomous robot that will be able to detect a fire and extinguish it using a pump. So our team comprises of 4 people. Aviral Prakash Pandey, who has worked on the physical assembly, the video recording, and the parts. Vaishnovi Arun, who has made the Tinkercad circuit design, worked on the coding, as well as resolved problems that we had faced over the weeks. Me, Vedant Palit, who has worked on the coding, the presentations as you can see, and the problem resolution as well. And Mitadru Datta finally, who has also worked on coding as well as debugging the errors that we were encountering in the code, the video editing, and problem resolution. So I would like to show you the Tinkercad circuit design. So what you see here is the Tinkercad circuit design that Aviral has explained in the later segment of this video in detail physically. So what we have used in the circuit is that instead of the pump, due to its unavailability on Tinkercad, we have used a vibration motor, which will basically react to the input that is being made in the temperature sensor. Now the fire sensor that we have originally used physically is different and works on the principle of infrared radiations, but we have used a temperature sensor here. And as you can see, these are the connections that we have made with the Arduino board, the breadboard, and the 2 DC motors, which are basically the wheels.
Now I'm going to explain the construction and the parts involved in the making of this firefighting robot project. So here I have 2 acrylic sheets which are joined through a series of nuts and bolts. Also we are using 4 wheels here which are connected to the respective motors, and the connections have been soldered properly in place. So here 2 of the motors are going to be driven externally and 2 are going to follow the code. The reason is because of this black thing here. So it has 16 pins and it is known as the L293D driver module integrated circuit. It consists of a dual H bridge and its main function is to act like an interface between the microprocessors and the motors. So this supports only 2 motors, so 2 motors have to be driven externally. We have our Arduino Uno R3 board, a mini breadboard to make all the connections. So the connections are according to the circuit diagram. We have a flame sensor right here. So this is just like an infrared sensor. It works like that. So and if you have a flame at a specific distance, it will sense it and the robot will move towards it. Now you can see here we have this container. So we have attached a pipe and the pipe is attached to this white device here, and this is the pump. So this is a 5-volt pump and this is also going to be driven externally.
So hello everyone, here I am going to explain the code for our model firefighting robot, and I am in my Arduino IDE. So first we have set a boolean variable fire equals to false. So at the neutral condition we don't have any fire, and then we have to define all the components which we are going to use in our Arduino connections. So we are going to use the flame sensor, the 2 terminals of the left motor, the 2 terminals of the right motor, and the pump, and this number signifies to which pin it is connected. So using the define function we basically assign a variable to our pin of the Arduino. So now using the void setup, we need to set the pin mode, that is whether our component will perform an input operation or an output operation. So forward S is our flame sensor, which is going to take input from the environment whether there is flame or not using infrared signals. So and the remaining are the output, right? The motors and the pumps are going to show output. So we set the pin mode using void setup. Then we are referencing a function void put of fire, which is basically going to first set all the terminals of the motor to high. So if all the terminals are high, there is not going to be any potential difference, so there will be no current flowing through them. So the digital right pump high, then the pump will be set to high, and then there will be a delay, and then again low, and then fire will be false. So what this function is doing, basically it is first stopping the motor since there is no current flowing, then switching on the pump, keeping it switch on for some time, and then switching it off. So and then also referencing fire as false because now there is no more fire. So now we need to write this void loop function, because we need to write the portion of the code basically which will run for infinite number of times. So why infinite? Because suppose the firefighting robots detect a fire for infinite number of times, like anytime it should detect a fire, it should move towards the fire, right? So we need to write this portion of the code in the void loop portion. So if digital read forward is equals to 1, so here 1 means low, we need to take care of this because this is an input function forward is, and so the pin of the Arduino 1 means here low. So digital write, if we are writing digital write, we are means we are setting the pins of the Arduino to a certain potential. So we have done all here high so that all at the same potential. We can make all low also. It is basically not going to move the robot if there is no fire. Else if the sensor reads something, then you have to move the robot forward. So digital right, you have to set high low high low. If we set low high, the robot will move backward. The variables we assign in such a way during our setup. So why high and low? Because if one terminal is at high potential and another is at low potential, then there is difference of potential, which means that there will be a current flowing across the two terminals of the motor, which means the motor is going to drive. So this is the basically logic. And then we are going to set fire equals to true, because because the fire sensor has detected fire straight ahead. So this delay function does not only delay, but it has also function of slowing down the speed of the motor. We saw here that the motor is moving forward, so we need to slow down it when it comes near the fire. So we put delay 300, and then while fire equals to true, put off fire. So this is the basically main portion where whenever till the time the sensor detects the fire, it should put off fire. What it's put off fire? It is the same thing which we have earlier referenced it. Same function, that it is going to switch off the motor, then set the pump high and then low, and then fire falls. This will keep happening until the fire is totally put off, until the fire equals to true. So yeah, that's all for our code explanation portion.